All right, let's talk about a design pattern that is, and I'm not kidding, an absolute lifesaver for any C# developer. We're diving into the adapter pattern. This thing is the secret sauce for making two totally different, incompatible pieces of code play nice and work together. It's a real game changer.
So picture this, you've got this awesome piece of old code, right? It's been around forever, it's battle tested, it just works. But now you've got to plug it into your shiny new modern system. So what do? How on earth do you connect them when they just don't speak the same language? That's the million-dollar question.
And that question leads us right to the heart of our story today. We're talking about the incompatibility problem. I mean, this is a classic, right? It's the age-old story in software. The old code meets the new code, and, well, they just can't communicate.
Okay, look at how simple yet so frustrating this can be. Our new system, it's expecting something that follows the iPrinter interface. It needs a method called print. Simple enough. But then there's our old trusty legacy printer. It does the exact same thing, but its method is called print document. And just like that, because of one little name difference, they're completely incompatible. They can't talk to each other. Maddening, right?
And you might think, oh, I'll just change the name. But hold on, because that's where the real trouble starts. That one tiny mismatch can cause some major architectural headaches. Yeah, sure, there's the obvious incompatibility, but the real danger is if you go in and start messing with that old legacy printer code. You're creating what we call tight coupling, and that, my friends, is a silent killer in big projects. It's when a tiny change over here causes a massive, unexpected explosion somewhere else entirely. Your code becomes brittle, your flexibility is gone, and pretty soon the whole thing is a nightmare to maintain.
But don't worry, this is not a horror story, because this is where our hero makes its grand entrance. So let's meet the adapter pattern. It's the elegant, clean solution designed for exactly this kind of mess.
So what is this thing officially? Well, the adapter is what we call a structural pattern. And its whole job, its entire reason for being, is to let objects that have incompatible interfaces finally work together. Think of it like a translator, or even better, a bridge that connects two sides that couldn't connect before.
And the best way to get this in your head is to think about a universal power adapter. You know, the kind you take when you travel. Let's say you've got your laptop with a European plug, but you're in a hotel in the US. You're not going to start rewiring the wall, right? And you're definitely not going to take a soldering iron to your laptop. No way! You just grab that little plastic adapter, plug it in, and you're good to go. It's exactly the same idea, but for your code.
Okay, theory's cool and all, but I know what you're thinking. Show me the code. So let's do it. Let's dive in and see how we can actually use this pattern to solve our little printer problem.
First things first, let's establish our target. This is what our new modern system is built to understand. It's expecting an iPrinter interface. This means that for anything to plug into our system, it absolutely must have a print method. That's the contract, that's the rule. All right, now for the other side of the equation. We've got the adaptee. In our case, that's the legacy printer class. This is the thing with all that great, valuable logic we want to keep using, but it's also the one with that pesky print document method. And here's the key. We can't change it, or at least we really shouldn't. Maybe it's a library you bought from another company, or maybe it's just so critical to the business that touching it is just way too risky.
And here is the magic. The printer adapter class. This is our bridge. You'll see it implements the iPrinter interface, which is exactly what our new system wants. It has that print method. But look inside. It doesn't actually do any of the printing work itself. All it does is take the call, turn around, and pass it straight to the print document method on our legacy printer. It's just a clean, simple, and beautiful translation layer. And check out the result. This is what it looks like when we actually use it. First, we create our legacy printer. Then we wrap it up inside our shiny new printer adapter. Then, and this is the important part, we hand that adapter over to our document editor. From that point on, our document editor has no idea the legacy printer even exists. It just knows it's talking to something that has a print method. So when we tell the editor to print, it talks to the adapter talks to the legacy printer, and boom, success. The job gets done, and our new system is completely oblivious to the old code.
Now, you might be looking at this thinking, that's a bit of extra code just to call a method. And you're not wrong, but let's zoom out a bit. Let's talk about why this approach is so much better in the long run than just hacking something together.
There are three massive wins here. First, compatibility. We just made two things that couldn't talk to each other, talk, and we did it without changing a single line of their original code. Second, flexibility. What if tomorrow we need to integrate a different old printer? No problem. Just write a new adapter. We never have to touch our document editor code again. And third, it's just good, clean code. We're following the single responsibility principle. The translation work has its own little home, keeping everything nice, tidy, and super easy to understand.
Okay, a quick but important point. It's really easy to mix up the adapter pattern with other patterns like Facade or Bridge. So let's clear that up. The adapter is all about converting one interface into another so they can work together. That's its main job. A Facade, on the other hand, is about making a really complex system easier to use by giving it a simple front door. And a bridge, that's about decoupling an abstraction from its implementation so they can change independently. Different tools for different jobs. So the big question is, when should you actually reach for this tool? When should that little light bulb go off in your head that says, aha, I need an adapter? Well, let's break down the classic signs. It really boils down to three main situations. Number one, you have a class you want to use, but its interface just doesn't fit the hole you're trying to plug it into. Number two, you're trying to bring old, valuable legacy code into a new, modern system, our printer example, basically. And number three, and this one happens all the time, you're using a third-party library, and surprise, surprise, it wasn't designed to work perfectly with your application's interfaces. In any of those situations, an adapter is going to be your best friend. And really, that's what it's all about. The adapter pattern isn't just about code, it's a philosophy. It's about building bridges instead of walls. It's about making things connect. So I'll leave you with this to think about. As you go back to your own projects, what incompatible worlds in your own code are just sitting there waiting for you to build a bridge?